Hi, welcome to How to Repair. In this video we're going to be looking at heating faults and thermostatic faults on Hoover and Candy tumble dryers. Now if you don't have an LCD display, you may have a blinking red light or multiple blinking red lights which could indicate an error with the heating system. On the LCD display or the Smart Touch, which is NFC controlled, you may be having an error E05, E08 or E21 coming up on the system. This indicates you've either got a thermostatic problem or you may have a problem with the heater. We're going to show you how to dismantle the machines because these are difficult to actually get into. They're not the best designed for maintenance, as I've said in my other review video on these machines. And first thing we need to do is disconnect the machine from the electric and take the lid off the machine. Now you will need a Torx screwdriver or a impactor with a Torx bit. Most of the screws are Torx 20, and to take the lid off there are 3 screws at the top which need to be undone. These cabinets are atrociously bad at disassembling. Once you've undone the 3 screws, this plastic trim needs to come off, and as you can see, even I'm struggling with this, and the reason being is the manufacturer have used chipboard laminated, and in a moist environment this chipboard can actually swell. Now this is a new machine, but it still makes it difficult for the lid to come off. So the plastic trim comes away and the 3 screws need to be organized together. Next, we need to pull this piece of wood out. Now, sometimes the plastic brackets will come with it, and in this case, I think they are coming off. And these are notoriously bad at coming off. And I've been doing this many years, and these are difficult to come off because they're chipboard. Put that safely to one side. Now we can remove the 2 plastic trims from either side. Okay, now we've got access to the top of the machine. We're going to take the facial panel off while it's on the floor so you can actually see. There are 2 screws at the top. Now do remember, when dismantling these machines, it is very important that you keep all these screws organized because there are about 5 or 6 different types of screw on the machine, and they're very important that they go back into the correct place. Now if you look closely at the front, we have a couple of catches here and here which you need to press down to remove the panel. And then the panel will come away. Now at this point it's worth taking a photograph of the wiring before disconnecting it. There are 3 plugs on these circuit boards, and you just have to press down the tabs to release the clip. There's one. This one's got a tab that pulls backwards too, and then you've got the main block of wiring. Most of these plugs can only go in one way. That allows us to remove the circuit board. Now there is a common fault on the early types of Hoover and Candy machines. Sometimes one of these relays may go faulty, but you can find all about this in another video that I've done, and I'll put the link in the description. Okay, we've put the machine back on the workbench so you get a better view. Next thing we're going to do is take the protective guard off the heater. Now at the bottom here there are some short screws going into the plastic, and as you can see they're about just over 1 inch long. Keep these separate. These are different to the ones that are used on the front. And under this heat protection guard, which stops some of the heat being wasted, you will find 3 more screws. Once you've removed that, you have access to the heater. There are a selection of thermostats and cutout around the element. You have 2 at the top here and 1 at the bottom here, which is actually pot riveted to the chassis, which I think is bizarre. But to actually get at the heater plug, it's behind the side cabinet. So we need to actually have access to that before we can start testing. So we have a selection of screws going up the side. You have 1 screw at the top, which is completely different to every other screw. We actually now need to remove the plinth covering the bottom to expose some screws. So I'll just slide this forward and tilt it backwards. And using a flat blade screwdriver, just put it in on each side and just prise it upwards slightly. And then you're able to remove the panel. Now it is possible to take the side panel off with a little bit of jiggling by undoing the 3 screws here and the 1 at the top, but really you do want to take the front panel off because it gives much easier access to it. Now the problem being with this is the door only opens so far. And unless you've got a specialist tool to get into the screws on these hinges, you actually have to take the door apart so you can clear the hinges. It only takes a couple of minutes to do this, but just to undo the screws going all the way around. These are all Torx again, apart from the one by the door lock. And the one by the door lock is a Phillips. Once you've got these undone, you're able to split the door. Just take your time and work your way round. You may need a flat blade screwdriver just to prise behind the plastic. And there is some polystyrene inside the door. And it can only go in one way. And then there's a piece that supports at the bottom here. Put that safely. Now you're able to close the door slightly and remove the 2 hinge points. Now you've got clear access to these screws. Trying to undo these screws at an angle you will find exceedingly difficult, and you could round the screw tips. Right, now we have 3 screws going round here. Okay, now we're able to remove the panel. There's two screws on the bottom. These are plastic type screws, and then you have the steel screws at the top. When I say plastic and steel, I'm meaning the type of threads that they're going into. And as you will see, they are much shorter. Once you've undone those screws, you need to tilt the machine back again, and you can see that there are 2 screws in the bottom. Although these are metal screws, they're slightly longer than the screws that I took out at the top. So do note that the longer ones go in the bottom. Once those are undone, then the panel will come away from the door seal. And hidden behind the label here is one last screw. And now the panel will come away. Now it's actually attached to the wiring on the door lock. So you will need to use just a small screwdriver and slide it slightly that direction when pressing the lug. And then the door lock will come off and the panel comes away. Now you have access to the forward thermostat, and here we have an NTC sensor. I'll just undo these last 2 screws. Just peel the plastic up on the corners, lift up the panel slightly, and the panel comes away. Now this is a much better design than they originally had. The original design is the side and the back was all one piece, and it was a nightmare. You had to take off the whole of this plastic to gain access to the plug for the heater, and also the motor, the capacitor, the belt and everything else. This is a much better design, but it's still a complicated design. Okay, we've got the machine apart and we'll start testing all the electrical system, and at the end of this we'll bring up the workshop wiring diagram for this machine so I can explain the circuit. And I've had a look at it and it's incomplete anyway from the manufacturer, and I'll explain all about that in a minute. The tumble dryers normally have a twin coil element in the heating system. This means you've got a button on the front of the machine or a cycle on the front of the machine, which is for low heat and high heat. This machine does not, and the reason I know it does not is because we only have 2 wires going to the element. This means that the element is one element in here, and the thermostatic system is what controls the temperature. Now we have 2 thermostats. The one that is pot riveted on at the bottom is a thermostat, and the one on the top right hand side is a thermostat. This one here is a thermal fuse. This means that when it goes above the design temperature, it goes open circuit and will stay open circuit. In other words, it blows. And the way you need to test all of these thermostats and thermal fuses is if you take one wire off each, and this bottom one I'm going to take both wires off because it's a difficult position, and we use my multimeter. Now I've got 2 multimeters here because I've got to check the NTC sensor, and this one will not work on the ohms resistance. So I'm setting this to continuity, and the thermostat at the bottom has got continuity. You can see on the meter there. That means it's good. The thermostat on the right also has continuity, and that means it's good. These 2 thermostats will cycle. That means at their designed temperature, say for example 60 degrees, that thermostat will go open circuit, and as the machine cools down, it will close the circuit and electricity will then be able to go to the element. So these 2 are good. The thermal fuse has also got continuity. All these are good. So first thing I'm going to do now is connect up the wiring to the bottom one. I'm also going to disconnect the heater plug on the left hand side, and we have a blue wire and a black wire here, and if I follow that through, the black wire is this one, and if I take off the blue wire with the plug undone so we don't get any false readings, and I do a continuity check or an ohms reading on my meter, we have 27.3 ohms resistance. This means that that element at 240 volts is correct. It's 2100 watts, thereabouts. There will be a slight difference as elements age and wear, of course. So that is the heating system all checked at the back. If these are all good and your tumble dryer is still not heating, we need to look at the forward thermostat and also the NTC sensor. Okay, the thermostats and the heater all on the back of the machine are good. This is the NTC sensor, which I will explain in a second, and this is a thermostat. Now when you see the wiring diagram, this thermostat isn't even showing on the wiring diagram, but there is some writing on the side of the thermostat which says 85C 4521. The 4521 I imagine is the manufacturer's number, but the 85C tells me that this thermostat cycles at 85 centigrade. So we should have a circuit on this thermostat. So if we set the meter to continuity like I did before and we do a reading across here, we have continuity. We know that thermostat is good. When it gets to 85 centigrade, of course, it would become open circuit until the temperature drops below 85, and then it will become a circuit again. This also would control the heater. Okay, let me explain what we've been looking at and checking all the thermostats before we check the NTC sensor. So I'll bring a picture up at the bottom for you. This is the thermal fuse. We have a red wire going into it and a blue wire going out. And where you can see my finger, these are the two wires that go down to the heating element. As we said, we only have one circuit on the heating element, therefore it would only need two wires. If you had a high and a low heat on the tumble dryer, then you would have three wires. One would be neutral and two would be the feeds. So we have a red wire here, and as you can see, the red wire goes here. This goes to the thermal fuse here, and then we have the heating coils. As you can see, they've linked the heating coils together, so it's one coil. Now, according to this, we have a black and a yellow wire, which should be attached to the other side of the element coming out. So if we follow that black wire going all the way up, the black wire actually goes all the way to here, which is the black and yellow wire, and then the black wire leads out. Now this black wire, there's that thermostat, and you can see the black wire here, and this goes to another thermostat. Now there are two thermostats on the machine apart from the two on top of the heater, plus an NTC sensor. One of them is not showing on this diagram for some unknown reason. We have two black wires going to this thermostat on the front of the machine, and we have two black wires going to the one underneath the heater. And I imagine that this one is the actual wire or the heat thermostat that they're showing here. And this says vented. So I would imagine this thermostat could be somewhere around a 65 centigrade thermostat, and the one on the top of the heater may be a higher value, somewhere in the region of about 85C. But also, as we saw earlier, the one on the front was a C85 as well, which means that it's got a cycling temperature of 85 degrees. Anyway, that comes out, but the NTC sensor is showing here. Here's the NTC sensor, but it's not showing this thermostat. Now, the NTC sensor, all it says for that is 035 Rosso, which is red in Italian. Now, I imagine the manufacturers know the NTC sensor values, because an NTC sensor should have a set value at a certain temperature, and then at a higher temperature it would have slightly lower value, and this way you can actually test the NTC thermostats. All of these thermostats on the diagram, none of them have any temperature of what they operate, and I think manufacturers should actually put this on the actual diagrams to say that the thermostat here is 65 centigrade, the thermostat here is 85 centigrade, and so on. And they should also put the NTC value. The last thing I wanted to quickly show you was the heating element. The heating element is a 2100 watt. As you can see, it's a single coil. This means that this element at 240 volt has a resistance of about 27 ohms. And that's basically the whole wiring diagram. You've got the printed circuit board here, the filter coming into the machine. This is a suppressor or filter. You've got the door interlock showing up here. Then you've got the motor wiring here. It doesn't show the capacitor, it just shows the motor wiring. And also the touch foil and the NTC sensor. And that's pretty much it on all the diagrams. There was 2 diagrams for this machine, but none of them are any different. They're pretty much the same diagram. So let's test the NTC sensor. Right, the NTC sensor is a preset value that tells the circuit board what temperature it is. Now, this is done using resistance, ohms resistance. Now, at a preset temperature, this NTC sensor would be a certain value, but the manufacturer does not put this in the workshop manual. So I'm going, because this is a brand new machine and we're running at roughly 23 degrees at the moment, I'm going to undo one a second, and I'm also going to put my test rig on here without touching the thermostat. And I'm going to put my jump lead in and connect up the multimeter and turn it to ohms resistance. And we should be able to see what the value is at 23 degrees. And then I will take the thermostat out so you can see it in operation. So basically, have I got a good lead there? No, I'm not on the correct. So at the moment we have roughly a 22.18. It's fluctuating slightly because this meter is not calibrated, but we got 22.1718 of resistance to the NTC thermostat at 22 degrees. That's the room temperature in here at the moment. Now, if I take off this thermostat and I put my finger on the end of the thermostat, we should see the value drop. So at the moment, 22.14, here it goes, it's dropping. 21.9, 21.8. Now, when I take my finger off this, it will cool down and therefore the value will start going up again. It will take a few minutes for that to take place, but if I take my finger off now at 20.7, it will take a few seconds, and I'll just put it back into location because that will help cool it with my finger away from it. And we can see that the value at the moment is 20.4. That means it's equalized, and now we should see the value start to go up as the NTC sensor cools. You must remember, when I put my finger on it, I did create some residual heat into it, but as you can see now, it's climbing, it's 20.5, and I'll just carry on putting this back in. So I hope that helps you, because the manufacturer does not state what the NTC value is on this sensor. They only just say NTC sensor and they don't tell you the value, so you have no way of checking it unless you know the value. But as you can see now, as the temperature is equalized, we're already back up to 20.78, 27.9, and it's climbing. So we know all these components are good. Now, if your tumble dryer is still not heating, you may have a problem with the circuit board. Now, I'm not going to bore you in this video because these are quite complicated videos. I have done a previous video on how to test NTC sensors and replace NTC sensors, especially on the Hoover tumble dryers and the Electrolux tumble dryers. There are common faults where the manufacturer has put in undervalued relays onto the actual circuit board, and sometimes these relays over a period of time can become faulty. Hoover used to have the problem and Electrolux used to have the problem. They might not have that problem anymore on these machines because this is a new type machine and they may have changed it. But I got to peel this label off, which I hate doing because they always stick. But I imagine this one to the left is the relay for the heater. And I can't read the writing on that, sorry. But it will have a number on the relay and it will either be a 6-pin, 7-pin or 8-pin. There's two other relays here. They would be for controlling the motor action on a right-hand rotation or a left-hand rotation. If it was a condenser dryer, you might have an additional relay because it would be controlling the pump or something else. But that's basically the whole heating system, and I'll quickly reassemble the machine. Okay, we've put the machine back together, and I will do a short little video for you with regards assembling the door assembly and putting the two halves together, because I never filmed it really in depth so you could see. So I will do that for you, but I'll quickly just turn the machine on to show you the power and the ampage that it draws. First thing I'll do, so we can initiate how much wattage the motor is drawing, I'm turning it onto a cool cycle, and we'll let the machine start, and we should see a wattage coming up. And if you look here, we're drawing about 180 watts, which is 0.8 of an amp. Now, if I stop the machine now and turn it off, and if we turn the machine to a heat cycle, and I'll just put it on the 45-minute and press start, you can see the machine is drawing, just wait for the heater to cut in, 2,260 watts. If you take away the 180 watts, that is showing us that the heater is drawing about 2,100 watts. And I'll quickly show you where to get the identification number on your machine. There is a label in the right hand side and sometimes on the back of the machine, and your model number, your full model number is there. So if you do need any parts for your appliance, remember you need the full model number to be able to identify the correct part for your appliance. The other thing I would say is thanks very much indeed for watching this video. Remember to support the website by buying the parts off us. And if we really helped you, please remember you can always click on the Bipolar Beer page, and that will help support the website as well. Thank you very much indeed for watching this video. I hope we helped you.